Buongiorno, buongiorno, benvenuto in matematica. So, just a little bit of Italian there. So, it's questions from Benny. Thank you very much, Benny. Hope you're doing well. This is a S1 question on the discrete uniform distribution. I'm not going to do it in Italian. I simply could not. Okay. English only. So, and that's the extent of my mathematics in Italian. Okay, I can't do any more than that. Anyway, let's move on. So I've just broken up this question into little bits, so you can either do this with me, or you can pause, have a go yourself, and then just have a look to see how it worked out, or you can just watch and enjoy. Okay. So the random variable W has discrete uniform distribution where probability W, because W is 1/5, and it's 1, 2, 3, 4, 5. The great thing about the discrete uniform distribution is that the probability is always the same. Okay, 1/5 in this case. Find the probability that 2 is less than equal to W is less than 3.5. Now it's discrete, which means no decimal values only, so 1, 2, 3, 4, 5. So what that really means is probability of W being 2 or 3. So 2 is inclusive, it's going to be less than 3.5, so 2 or 3. So probability of 2 or 3, each one being 1/5, so it's 1/5 plus a fifth, which is just 2/5. Okay, so that's the first part done. The discrete random variable x is 5 minus 2w. Find expected value of x. So the first thing we'll do is work out the expected value of w, which is 3. So let's just pause there for a moment to understand why that is. When you've got a discrete uniform distribution, you can use the simple formula of 1% over 2, as long as it's from 1 to n. Okay. Or alternatively, what you can do is, because it's a symmetrical distribution, the mean, median, mode, they're all the same. Well, in this case, the mean and median in particular. And the median is 3, that's also the mean. Or alternatively, if you don't believe me, you just add all those numbers together and divide by 5 and you'll get 3. Anyway, the expected value, the mean of that is going to be 3. What we need to do is work out the expected value of this. So 5 minus 2w, and that's just the same as 5 minus 2 times the expected value of w. Okay, and since we know that E of w is 3, you get 5 minus 2 times 3 equals -1. Okay, bellissima! Next. Go. Random variable w. Again, I'll find probability x is less than w. Right. So let's just write down what that actually means. So x is 5 minus 2w. 5 minus 2w less than w. Rearrange that, make w the subject. Here we go. Probability 5 is less than 3w. So probability w is greater than 5/3. Remember, it's discrete again. So 1 and 2/3. Greater than that, that means it's got to be 2 or more. So w is greater than or equal to 2. So what that means is this will be the numbers 2, 3, 4, or 5. Okay, each one being a fifth. So 1/5, 1/5, 1/5, 1/5, 4/5. Okay, grande. Next, find probability distribution of y. Right, so y is 1 over w. Now, probability distribution normally means that we draw a table. Okay, a table that looks like this for y. So you've got the y values and probability of each one individually occurring. So y is 1 over w, so 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5. Can I just cross it out, because I didn't mean to write 0 there. No, because 1 over 1 is 1. Yeah, so 1/2, 1/3, 1/4, 1/5. And again, because it's discrete uniform distribution, each one of these is going to be just 1/5. Quite easy, really, isn't it? And that's that. That's the probability distribution of y. Find the variance of y, showing you're working. So for the variance of y, you need to be using this formula here. Variance of y is e of y squared subtract e of y all squared. Notice the brackets. So e of y squared subtract e of y all squared. So find e of y first. So from the table, you can just do that times that, plus that times that, plus that times that, plus that times that, plus that times that. So, in short, because you're multiplying all by a fifth, you can do a fifth times 1 plus a half plus. So, I wrote the 1 there. I don't know why the 0 occurred there. We'll forget that happened. So, yeah, and that gives you 137 over 300. So, for this one, e of y squared, you want to square these values first and then multiply by the probabilities. Okay, so you end up with this. So, 1 squared times a fifth, half squared, which is a quarter, third squared, which is a ninth, a 16th. 1/25. Again, all multiplied by a fifth, so just take the fifth outside the brackets, and you get this. Not particularly nice fractions, okay, but there you go, the fractions nonetheless. And then you just substitute them into this here, okay. So e of y squared, which is that, subtract e of y all squared. Don't forget to square that. 137 over 300 squared, and that gives you this. Why is a decimal at this stage? Okay, usually in S1 decimals are perfectly acceptable. Okay, so I'll put that there to 4 decimal places. And there's one more part of the question. So find this. So just as a reminder, okay, variance of y is 0.0842, and yeah, so the variance of this. You just got to know the formula for that. That is, just give you a quick reminder. When you've got variance of ax plus b, the plus b makes no difference, and you do a squared times the variance of x. Okay, so that's why I've got the variance of y there on standby. So you can do negative 3 squared, which of course is the same as 3 squared. Okay, and yeah, 3 squared, 9 times by that gives you 0.0842, 0.758. Okay, I'm hoping you got something out of that. Hope you enjoyed it. Okay, arrivederci, bye bye, ciao.